आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़।
Celebrating Azadi Ka Amrit Mahotsav, we bring you a podcast series on STEM popularization, science, technology, engineering, mathematics and medicine, supported and catalyzed by the National Council for Science and Technology Communication, Government of India. This program is produced by Media for Community Foundation. Creative content and technical support is given by Purvasha Banerjee and Shushanto Das.
एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़, की आवाज़।
Vigyan Ki Awaaz podcast series aims to popularize new ideas of science and technology, which highlight STEM, science, technology, engineering, mathematics, and medicine. This brings to the surface the efforts and researches of Indian scientists, which is desired to bring a change in community learning and teaching, access to knowledge of resources, and social paradigms. Our goal is to spread the name of indigenous Indian research stories and their masters among the masses of society in a very easy manner. Bose Institute was set up in 1917 by Sir Jagadish Chandra Bose, the founder of modern science in the Indian subcontinent. It is Asia's first modern research center devoted to interdisciplinary research and bears a century-old tradition. The institute was founded as not merely a laboratory but a temple, with its principal aims being the advancement of science and diffusion of knowledge. Swami Vivekananda, Sister Nivedita, whose influence is reflected in the institute's emblem of Vajra, was significant in the setting up of the institute, and Rabindranath Tagore were among those who had consistently inspired and supported Jagadish Chandra Bose in his endeavors. Ever since the establishment of the Department of Science and Technology, Government of India in May 1971, Bose Institute has been an autonomous grant-in-aid institution of DST. Over the last century, the institute has endlessly strived to preserve the legacy of its illustrious founder. In this podcast, we are glad to present Professor Supriya of Bose Institute. We shall know in detail about his work, but before that, a few words from his own voice about his own self.
I am Supriya Das. I work as a physicist in Bose Institute. If I start from my PhD, I did my PhD at the Variable Energy Cyclotron Center here in this city itself, and where I worked for a detector, a photon multiplicity detector, which was a detector built in India by several institutes, including VECC, and this detector was built for an experiment that was performed in Brookhaven National Laboratory. The detector sat there in that experiment solenoidal tracker at RIC. RIC is an accelerator which accelerates particles in ultra-relativistic energies, and those particle collisions, those heavy ion collisions, we study by using those detectors. So one of those detectors was photon multiplicity detector. My role in that during my PhD time was development and fabrication of that detector itself. That detector is based on gaseous detector technology, where we have gas and then there are electrodes. You apply high voltage. When charged particles go through those detectors, it ionizes those gases inside, and those electrodes with high potential, electric potential, they attract those particles inside the gas, and in this process it multiplies. Large number of charged particles is created, and then that gives a signal, electrical signal, and in this process you detect that charged particle which goes through that detector. And these experiments where heavy ions are collided at ultra-relativistic energies, heavy by heavy I mean heavy in the periodic table, which has mass like lead, like gold. So in that particular experiment, STAR, which is the solenoidal tracker at RIC, we collided gold on gold at 200 GeV, giga electron volt energy. So one beam with 100 giga electron volt, another beam with 100 giga electron volt, they collide each other at the center of mass energy of 200 giga electron volt. The goal of this experiment is to create a primordial soup of matter which existed at the beginning of universe. So the goal was to create and mimic the matter which existed at the time the universe was created and right after that. If I continue from that, so after my PhD, I did my postdoctoral research in another experiment which is in GSI, that is in Germany, Darmstadt, Germany, where a new accelerator complex is being built. So that experiment was at that time in planning phase, where I worked for another detector, and then I came back here in Bose Institute.
Professor Dash says about his present and past collaborators in the field of his experiment.
When I joined in Bose Institute, there was no group, experimental high energy physics group here in Bose Institute. It actually started after I joined. After I joined, I started talking with my colleagues who was there in these projects, earlier projects, and then I took an opportunity to enter into this collaboration. I took Bose Institute in that collaboration, and then I started working, building the group. Two other faculty members joined here in this group, and we kind of work together in this experimental high energy physics group. The basic idea of this group, working in this group, is doing those kind of experiments, developing the detectors, developing the software codes to analyze those data, and analyzing of those data to find the physics goals. In this institute, we are 3 or 4 of us in this group, Professor Sanjay Ghosh, Professor Soikat Biswas, Dr. Siddharth Kumar Prasad. And in India, we have 11 or 12 institutes and universities, where in this city itself, VECC, the Variable Energy Cyclotron Center, and the Saha Institute of Nuclear Physics, there are groups which we collaborate with. And we have a larger global collaboration where a lot of institutes are also working in these kind of experiments where we work together. So this is a kind of competition along with collaboration. So we work hand in hand, we compete with each other in these groups to publish our results, to get the results sooner than the other people. But then at the same time, we work together to build these kind of experiments, the detectors, etc.
Professor Dash shares about his experiments and his area of present work.
Currently, I am working in 2 experiments. In one experiment, that is a planned experiment which will take place in few years from now, when this facility for antiproton and ion research at Darmstadt, Germany will be built. So in 2-3 years from now, so there will be an experiment called the compressed baryonic matter, which will probe the matter which actually exists in within the astrophysical objects like neutron star, which is a very, very dense object. So we would like to probe that matter, nature of the matter in that kind of astrophysical objects with heavy ion collisions. So there, particularly one project I am working with the correlation fluctuation of hadronic production, so protons and neutrons. So that will tell us about the location and nature, and if there is a tricritical point in the phase diagram of quark-hadron phase transition. That is in particular one experiment. And another experiment I am working is in a large ion collider experiment, which is at the LHC, Large Hadron Collider at CERN. There, my role is the group leader, and our colleagues are working there for another kind of experiment, another kind of physics goal, which, as I said in the in my introduction, that the early phase of universe, when the universe was created, how the matter existed, what was the nature of the matter there.
Professor Supriya explains about the connection of his work with our day-to-day life. His valuable words will guide the future generation to walk on the right path in the field of science and human life as a whole.
This kind of research and this kind of work it is difficult to see the connection with the society or societal application. But I can give you two examples from earlier days. So, two things. One is about the touch screen of your mobile phone, and the next name, of course, you will know. But this thing was first introduced in the control room of superproton synchrotron at CERN. The control room control panel was the first touch screen ever made. So this is one kind of offshoot from that. So it was first exercised in a high energy physics experiment, accelerator experiment. And next one, I think we all know, WWW, that was invented at CERN. So, and these two are not the only ones. So a lot of technologies that are being developed for this kind of experiments, they come into the societal applications after going through a lot of different developments and final product. So it is difficult to find the connections, but it is, as I said, the high energy physics experiments are kind of birthplaces of many new technologies.
Professor Dash shares his collaborations in Pan-India and in the city as well. We shall now be introduced to his global collaborators, contemporaries, and also competitors.
We are part of Indian Institute, in a consortium in India where Indian institutes and universities are involved. But at the same time, we are part of a global collaboration where the collaborators from Germany, from America, from Switzerland, from other European countries are also involved. If I have to say something very specific, then Switzerland is a place where CERN is, and Germany is the place, Darmstadt, Germany is a place where the fair is coming. And then, as I said, I did my PhD experiment at Brookhaven National Laboratory in New York. America definitely is in a big way in all these experiments.
We want to know where India is at present or in which rank on this particular area of research. He will enlighten us about our country's position.
It's a tricky question to answer in a straightforward way to tell you about the rank of India, but I think I can tell one thing. When this area of research first started in India in the 1990s, this area of experimental high energy physics, I would say, then India used to build detectors, go to the experiment, take data and participate. And now I can say, as I mentioned about the FAIR, Facility for Antiproton and Ion Research, where India is the founding member of a consortium of 9 countries and one of the founding members of this accelerator. I think that can answer your question in an indirect way. Where is India in this game of global science? I would just add up a little bit on this thing. So it is not just industries. As I said, that the experiments gives birth of different technologies. But at the moment, when I said that India is a founding member of this Facility for Antiproton and Ion Research, a lot of Indian industries are involved where India is supplying in-kind contributions to the construction of this accelerator. We are building special type of power converter. We are building special type of cable and a very special item which is a beam stopper which will be used in the FAIR accelerator that has been designed in India by Indian scientists. One Indian institute, CMERI in Durgapur, the Center for Mechanical Engineering Research in India. Their scientists are involved and scientists from BECC and our place are involved in designing that. So the complete design and the fabrication of that particular item is being done in India. So a lot of Indian industries are directly getting benefited from this.
We are thankful to Professor Dash for providing us with his valuable time.